Hello everyone. This is Dr. K. Shaktiraj, working as an assistant professor in Department of Physics, Kamaraj College of Engineering and Technology. In this video, we are going to discuss about engineering applications of ultrasonics. As we know very well about ultrasonic wave, that is a high energy sound wave. Because of their high energy, which can able to penetrate the thicker objects, so that which is highly interested in both engineering as well as in the medical field. In this video, we are focusing our idea only to the engineering applications of ultrasonics. In this presentation, here we have to focus two different type of engineering application. One is called sonar and another one is non-destructive testing. First, let us going to discuss about sonar. The abbreviation of the word sonar, that is sound navigation and ranging. With the help of these high frequency sound waves, we can easily measure the depth of the sea or the distance of the enemy's submarine or any kind of icebergs are present under the sea level, and also which is highly used for a fisherman to identify the school of fishes present on that area. So, how can we use the ultrasonic wave to detect these kind of obstacles? The basic principle behind the operation of this sonar is when ultrasonic wave meets a boundary which separate two different type of medias. So, always when ultrasonic wave meet the boundary between the two different medias, definitely it will get reflected. With the help of this, we can easily identify the depth of the sea. Here we can see that is our ultrasonic source. That ultrasonic source send ultrasonic pulses to the sea water. Finally, the ultrasonic waves reach the sea bed. So, here we can see that is a boundary which separate two different medias. So, definitely the ultrasonic wave will get reflected and it revert back into the same ship which they are originated, and the reflected wave once again captured by the detector which is also present inside the ship. So, the whole thing, the total time duration for the whole movement of the wave inside the water, that is easily measured with the help of some timer. So, now we got the time duration between the to and fro motion between the sending and receiving pulses. The time we call it as t. So, t is a total time duration between the to and fro motion inside the liquid media, right. And we should know the velocity of ultrasonic wave in the given liquid. So, initially we must find the velocity of ultrasonic wave with the help of ultrasonic interferometer. There are a lot of sophisticated instruments are available to measure the velocity of ultrasonic wave in the given liquid. Simply with the help of ultrasonic interferometer, we can easily measure the velocity of the particular ultrasonic wave through the sea water. So, initially we should know the V value, then when we know the t value from the timer, we get the t value. When we know the V and t value, finally we get the depth of the sea or depth of the submerged submarines or the distance of the school of fishes from the surface. That can be easily measured with the help of formula called Vt by 2. You may get one doubt like that, why we need to, the simple definition, velocity definition is displacement per time. So, V is nothing but d by 2, but why we need to divide the equation by 2? The main thing is here we are considering a time duration for both to and fro motion. So, actual depth of the sea is half of the distance travelled by the waves. So, that Vt by 2, that formula which is used to measure the depth of the sea with the help of ultrasonic wave. Another one question may arise in your mind, why I need to use ultrasonic wave in this case? Because ultrasonic waves are slightly affected by the sea water. Their diffraction and absorption phenomena are highly reduced inside the sea water. So, with the help of this we can simply measure the depth of the sea. Right. Next we enter into the second part of our application, that is called the NDT, that is non-destructive testing. There are two different type of testing methods, destructive testing, non-destructive testing. What is the difference between these two? When after the testing is completed, if the specimen is not damaged by the testing processes, that we call it as non-destructive testing. Suppose if when we test the specimen, after the testing is completed, the entire specimen will damage or degraded by the testing processes, we call it as a destructive testing. Simply, I would like to give one example for you. You have one egg. How do you find that egg is a good one or a foul egg? The simple experiment, first when you break the egg, if the yolk and albumin of the egg mix together, it means that it is a foul egg or it is a bird egg. But once you done that experiment, you cannot be able to reconstruct the egg, but you can do the same work in a different way, that is in a non-destructive way. When you simply put the egg inside a glass of water, when it is sink, it means that it is a good egg. When it is float, it means that it is a foul egg, because foul egg it always creates some kind of gases inside that eggshell, so that this produce some buoyancy effect, so it will lift the egg to the top. So, when after this second type of testing, we can use the egg for further tracing processes. So, that second type of testing method is highly interested for our everyday life. So, that non-destructive testing is a very essential tools in an industry for to identify any kind of flaws, or if we need to measure the thickness of the objects, size of metal sheets, we need to use this kind of ultrasonic wave. Right. This is a schematic diagram of the NDT technique using ultrasonic wave, and this is our testing specimen. The thickness of the specimen is D, and here we are considering one flaw is present at the depth D1 from the surface of the specimen, right, and that is called the ultrasonic transducer. The transducer receive ultrasonic pulses from the pulse generator, and the received reflected signals, which will be amplified with the help of signal amplifier, and finally the amplified signal is fed into the CRO. It simply visualize what kind of things is going on inside the NDT circuit, right. Initially, when the transducer is when the transducer is here, the ultrasonic pulses sent into the sample. So, initially the pulse sending from the air media to the solid sample, the first reflection takes place on the top plane of the sample. So, that we will get the first reflection from the top of the specimen. We know the basic principle of reflection of ultrasonic wave. When the ultrasonic wave meet the boundary between the two different media, it will get reflected, right. So, in this particular plane, the ultrasonic waves are initially reflected on the top, then some amount of rays are now enter into the specimen, and the second reflection which is happen on the point B. So, some small size of fly is present here, so that the fly is nothing but it will contain some amount of air or some other media is present there, so that it will create another one reflection, right. That reflection is that we get it from here, that is called echo from V. Echo is nothing but reflected sound wave, we call it as echo, right. So, we get a second reflection from here, and the third reflection which is from the bottom of the specimen, right. So, that this is a peak which we are getting from the bottom or back wall reflection. This is our initial top plane reflection, and that one is a reflection from the back wall. Actually, this particular CRO working based on the x axis time, y axis, it measures the amplitude of the signal. So, the difference between the top reflection and the echo plane, the difference value T, when we substitute the formula, we get the depth of the flaw from the surface of the specimen. Similarly, when we measure the time difference between the initial pulse and the back wall reflection, we get some time. When we substitute the time here, we can easily measure the thickness of the specimen. There are three different type of NDT methods. One is called pulse echo method, another one is called through transmission method, third one is resonance method. Till now, we are discussing about the pulse echo method, because the signals, that is ultrasonic wave, sent into the specimen from the top of the specimen. The bottom surface of the specimen is not accessed by the transducer. So, here we are using only one transducer which is present on the top of the specimen. So, that is why we are sending pulses and we are receiving echoes from the specimen that could be analyzed by the circuit. Finally, we get the depth or thickness of the distance of the flaw, right. Second thing, now I would like to show you one small video clipping which can able to explain the concept which I already explained you. Here you can see that one cylinder, metallic cylinder is here. The external appearance, it does not show any kind of flaw is present in it, it is looking so smooth. That is our ultrasonic transducer. It can able to send the ultrasonic pulse as well as it can also receive the ultrasonic pulse. So, for all the measurement you should always use some kind of couplant, because that couplant it reduces the amount of ultrasonic wave reflected back to the sky. Once we use the couplant over the surface, then the initial pulse, here we can see that when we move the transducer over the surface of the specimen, we can easily get the information about the different kind of things present inside the specimen. Here we can see that is our initial pulse, and that is from the back wall reflection. So, in this specific position we do not have any type of flaw. Now, the transducer is slowly moving at some particular position, especially in this case. Here you can able to see another one kind of flaw which is present inside the specimen. Yes, here you can see that some kind of flaw is present in this area, but visually we cannot able to identify the flaw, but with the help of ultrasound we can easily detect it. Here we get another one peak. So, it means that another one different kind of flaw is present on this specific area, but our human eye cannot able to see the such kind of flaws, right. So, from this picture we can easily visualize the size of the flaw and the thickness of the flaw present inside the specimen. That particular animation will show what are the different kind of flaws present inside the specimen. Right. Next, we are move on to analyze the second type of NDT method, that is called through transmission method. The basic difference between the pulse echo method and through transmission method is, in the case of pulse echo method, we are using only one type of transducer. It can act as both ultrasonics wave sender as well as receiver. But in this case, here we are using two different type of transducer. One can able to send ultrasonic wave, the another one transducer which can able to receive the ultrasonic wave sent by the sender. So, in this case the main problem of this method, we need to access both the sides of the specimen, right. In our previous case, we do not want to access the bottom space of the specimen. In this case, we should access both the sides of the specimen. the ultrasonic waves are sent into the specimen and it will be received by the another one transducer on the other side. So, that when the so initially we will get a signal at the beginning of the or the entry of the specimen. After that, when we receive the reduced intensity on the opposite side of the transducer, it means that some kind of fly is present on that area. When we move our transducer here we do not have any defect. So, that simply it shows only one peak with reduced intensity compared to the incident pulse. But if there is any kind of noise there, we will get the two different type of pulses on the receiving end. So, that this type of method is quite tedious compared to the pulse echo method. Now, I would like to show you what are the basic advantages and disadvantages of NDT method. As you know very well about it, the circuit of this NDT is very simple, is very cheap compared to the other type of deduction methods. So, it is cheapest, the results can be immediately recorded from the NDT specimen, right. So, the first thing, we can use this kind of method for all kind of specimens that does not have any type of restrictions for use these kind of waves. So, we can apply this ultrasonic wave for any kind of surfaces, right. The second one, even we can apply these waves for to measure the small size of specimens. Third thing, the total arrangement, total setup is very small, compact one, is easily portable, and we can get the results immediately. We do not want to wait for a processing time, immediately we will get the result, which is very cheap, and we can easily maintain the permanent records for future references. But it also has some drawbacks. The main drawback, it need a highly skilled operators for to operate the instrument. Second thing, irregular shape of objects, we cannot easily measure it, because the ultrasonic transducer must be moving over on the smooth surface. So, that irregular shape of objects, it needs some special attention to measure it. Third thing, estimation requires some standard specimen. Before going to analyze the specimen, we need to analyze the standard specimen before enter into the final one. So, I hope you got a lot of idea about the engineering applications of ultrasonic waves. Thanks for watching. We will meet you on another one video soon. Thank you.